Junior Certificate, Higher Level 2012, Phase 2, Paper 1, Question 7. This is a sequences in series question. It might involve a little bit of coordinate geometry in terms of plotting points and drawing lines and coming up with a formula for the line, but we'll just work our way through and see what happens. So we have a set of data here. We have our units used going up in hundreds, so it's 100, 200, 300. So it's important to appreciate that it's not 1, 2, 3, 4, 5, but it's 100, 200, 300, 400. And we'll come back to that a little bit later on probably. And then our values for Plan A in terms of costs, we're adding on how much? You're adding on 18 each time to get to the next number. And since we have this common difference, as in the difference between one term and the previous term is plus 18, that common difference is the same every single time. Any term you get, and if you look at it in comparison to the previous term, it's always 18 more. So we have our common difference. Therefore, we can say that it's a linear pattern, linear sequence. So just to remind you, if the common differences are the same, it's linear. If you found that it was the second level differences that were the same each time, it would be quadratic. And if you don't have any sort of common difference pattern, and in fact what's going on is it's a multiplying from one to the next, then it's we call it an exponential pattern. Moving on to part B, we're asked to draw a graph showing that relationship. So basically the data that we were given, we're asked to plot it and show it on a graph. Now, since it's a linear pattern, we should find that the points are collinear, they're in a straight line. Now the axis up the side is not ideal because it's doesn't allow us very well to actually mark on the other values. I'm just going to put on the 50s and the 100s just so you can at least see that. So 138, so that's going to be a point about there. 200 is 56, that's a point about there. 300 is 74. 400 is 92. 500 is 110. 600 is 128. Now, to be honest with you, it gets to the point where actually you could probably just get your ruler out and just draw the line, but we'll just do them all. 700 is 146. And due to the nature of what I'm using here, I might be slightly inaccurate. You can probably be far more accurate using a decent pencil, sharp pencil. You better mark your points off reasonably well. But you can see there that there's a straight line. Now, as I said to you, mine's not particularly accurate, and I can tell you why I know mine's particularly not accurate, because part C asks you for the estimate the standing charge. So the standing charge is the amount that you get irrespective of how many units you use. So a standing charge, generally speaking, you can get that by appreciating, well, what if you had no units used? So what we're talking about here is the intersection with the y-axis. Where is this line intersecting with the y-axis? Well, it looks as though it's about 18. So what I should do is write down the fact that it's 18 euros. Now, all I would say to you is that that's not actually the accurate answer. If you've drawn your graph accurately and drawn your line accurately, what it should be actually is 20 euros. But what I would say to you is, whatever your line actually gives you, okay, since it asks you to use your graph, whatever your graph tells you, you should use. But ideally, you should have drawn your graph accurately. Moving on to part D, we're now asked to write down a different method for finding the standing charge. So basically what they want you to do is do it through a numerical process, so looking at the numbers and coming up with a formula, I suppose. Well, actually, not a formula yet. All they're wanting you to do is finding out the standing charge. Okay, so if you think about the data we had in the previous page, we had seen that we're adding 18 to go on to the next term. So if I said to you, if you remember, I said to you that if you think about the standing charge being for 0 units, well, if we went back in the other direction, we'd have to do the opposite. So take away 18. If we take away 18, we get to 20. So our standing charge would be 20 euros. And this is the point about what I said to you. Even if your graph is wrong, you'd still put whatever answer that you get from your graph down. Okay, in terms of moving on to later on in this question, you can be taking this value here because you've been able to find the accurate value using a numerical process going back to 0 units, your 0th term, the one before the first term. And finally, before I move on to part E, what I would say is if you had found at this stage the Tn expression, the nth term or the general term expression, the formula that describes what's going on, you could use that to find out your standing charge. What I'll do is I'll go through part E, I'll get my formula, and then I'll show you what I mean. So we're adding on 18 each time, but as I said to you right at the beginning of the question, we're adding 18 euros on for every 100 units that we use. Now, I suppose we could do this a couple of different ways, but what I would say to you is that that's 18 euros that we're adding on for every 100. So if you think of 18 euros per 100, well, that works out as 18 cent per unit. So what we'll do is we'll look at this. We'll take this into account when we're looking at our sequence. So our sequence is this process of 38 and 56 and 74 and 92 and 110. We've already found out that there's a standing charge of 20 euros. And when you think about that 38 is made up of 20 and 18. The 56 is made up of 20 and 36. The 74 is made up of 20 and 54, and so on, and so on, and so on. And so if we think about our sequence, we've got the 20 each time, and we've got this other number. And this is where this 0.18 comes in, because that 18 is made up of 100 of 0.18. And this number here is made up of 200 lots of 0.18. And the 54 is 300 lots of 0.18. So what we've actually got as a sequence is we've got 20, and we've also got 100 lots of 0.18. We've got 20 and 200 lots of 0.18. And so on and so on. I'm going to run out of space a little bit here. 20 and 300 lots of 0.18. So for n amount of units, we're going to have n lots of 0.18 plus the 20 euros standing charge. And so our formula in general, our Tn expression, is going to be 0.18 lots of n plus 20. Now I did say if in part D you found out this formula, you could work out the standing charge by appreciating what the T0 would be. So if I do T0, I'm substituting 0 into the formula, and I get my standing charge that way. Now, some people might think that this has been a slightly circular process because I use the standing charge to get my formula, but depending on whichever way you come up with your formula, if you put 0 into your formula, you get your standing charge, and that's perfectly acceptable as a method. Now moving on to part F, we're going to use that formula. We have our Tn expression, and we're told in one particular month she used 650 units. So T 650 is going to be 0.18 lots of 650 plus the 20. Now, when you work that out on the calculator, 137 euros. But they tell us that after VAT it's 155.50. So it's a case of appreciating what the extra amount is and finding out that as a percentage of the original amount. So my VAT rate is going to be the difference, the actual VAT that was added on, and I'm going to divide that by the original amount. We have 0.135, which is, as a percentage, is 13.5%. Moving on to part G, we have another plan, plan B, and in this question we have a standing charge of €36 and a unit rate of 15.5 cent, 15.5 cent. And we're asked to work out how much the plan would be for each of these different sort of usage amounts, 100, 200, 300, 400. Okay, and we're asked to put our values into here. There's a bit of space here to do some workings. I'll show you a few of them. You should show at least one or two of your workings. The rest of it you just do on your calculator and just bang in the answers. So each calculation, I have 36 as the standing charge plus 100 lots of 15.5 cent. Notice that I've converted my price into cent. Since I'm working in euros, I want my answer in euros, so I'm having my unit price in terms of euros. And that as an answer is €51.50. Your calculator would obviously say 51.5, but you need to make sure that you add in the second digit 0, just to put it in money format. And I can carry on doing that. I could do 36 plus 200 lots of 0.155, and I get €67. And if I carry on doing that as a process, I get 82.50, I get €98, I get €113.50, I get 129, 144.50, and lastly 160. As a quick aside before I move on, just to say how I was able to work out those quite as quickly as I did, was once I'd done the first couple, I realised that basically okay, I could do that each time as sort of described here. Now, and I could each time go back into the calculator and just change the hundreds in the calculation to the next one would be 300. But another way of it would be to say, well, I've got my answer, and all I'm doing each time is adding on another 100 units used. So on your calculator, if you were to do answer plus 100 times by 0.155 and just continue to press equals, 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 you'll get the values that you see that I've written on the left hand side here. I'm taking my previous answer and substituting in and adding an extra 100 units. Whatever my answer is, that goes in again as the next answer. So every time I press equals, it has a new answer substituted into the equation. In part H, we're asked to compare the two plans. So what I'll do is I'll just write out the plans for the values for plan A. And you'll see up as far as €600, you'll see that plan A is cheaper. So basically 38 is cheaper than 56 is cheaper, 74 is cheaper, 92, 110, 128 is just €1 cheaper than plan B. But once you get to above €600, when you get to €700, for example, we find that plan B is actually cheaper than plan A. So it really depends upon the usage. Now, in a previous part of the question, it mentioned about Lisa having been charged 650 units 1 month. So what do we have for 650 units? Well, for plan B, we have this rule of 36 plus 650 lots of 0.155, and we get a cost of 136 and 75 cent. That's exclusive of VAT. And the bill for plan A, worked out from the previous question, was €137 excluding VAT. So we can see at this stage for 650 units, B is a slightly better option. And the key summary here is that up to about 600 units, plan A is cheaper. From 650 approximately onwards, plan B is a better option. Now, where the exact sort of point where they cross over, we don't know yet. In fact, we're being asked to work that out in parts I and J. But at this stage, all they're wanting is just a rough idea. So in this instance, if we're assuming that Lisa uses 650 units, then we want to say as an answer plan B. So in part I, we're asked to, on the diagram, to plot in, as well as of plan A, we're also asked to plot in plan B. So on the previous page, we've got the graph and we can plot our points. And then draw a line. Now, I said beforehand this is not particularly accurate using the instruments I'm using here, but we're getting a break-even point at some point in time after 600. It's approximately at 620, sorry. I'll go with that value. And suggest that 620 is my is my sort of swap over my equalization sort of value. And put my answer in for part J. And before I finish, we must just quickly show algebraically what the exact answer is. So it's about equaling the two plans to each other. And then it's a case of solving that linear equation. And we get the answer of 640 units. So that's the exact answer, but it's very much a case of what your graph tells you, and whatever you read off your graph, wherever those two lines intersect, mark the point and show it on the graph, and then write it down for J. But we expect to get something between 600 and 650.